Good day, folks. Welcome to Price Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at type of question under organic chemistry, right? But specifically nomenclature. So now, letters A to H in the table below represents 8 organic compounds, right? Let us be in a position of identifying their homologous series, functional group, and all of that, right? So when I see here, I see here, let me check. CH3, then CH like that, CH2, CH like that. So here I see a haloalkane, okay? Haloalkane. I see a haloalkane there because why? I see a Br there, okay? I see a haloalkane, a Br, okay? Then, yeah, that's all. Haloalkane. Number B, I see an alkene. I see an alkene that has double Y because I see double bond here, right? I see a butene, okay? But2-ene rather. Then number C, pent2-ene, okay? This is also an alkene, all right? This one goes with the name of but2-ene, okay? Then CH3, CH2, CH2, CHO. Is this alcohol or aldehyde? Let's see. CH3, CH2, CH2, CHO. Okay, so this is an aldehyde. Okay, if it was alcohol, it was going to be, can you see? It was going to be OOH. But now, since it is double bond OH, and now the double bond O, it is now on the terminal carbon or the first carbon, is now an aldehyde, not a ketone. Okay, an aldehyde, remember the homologous series, it is aldehyde. Now the functional group, it is what? Formyl. Formyl group, right? Butan 2-one, this is an alcohol. Okay. 4.4-dimethyl pent2-ine, this is an alkyne. Okay. Butane, this is just an alkane. CH3, CH2, CH2, COO, this is a carboxylic acid. Why am I saying this is a carboxylic acid? I see with a COOH. Remember, it's going to be CH3, CH2, CH2, C double bond OOH. This is why you refer to it as a carboxylic acid. And the carboxylic, okay, functional group of alcohol, it is hydroxyl group. This one functional group of it is what? Carboxyl group. Okay. Very good. Now we are in a position of saying, okay, let us answer the questions that follow thereof. Okay. Write down. Oh, this is not an alcohol, sorry. Butan 2-one. Remember, the one, it is a ketone. Okay, alcohol, it is butan 2-ol. Okay, so this is a ketone. Okay, therefore its functional group, it is what? Its functional group, let me come back to that. Its functional group, it is a formyl hydroxyl carbonyl group. And now I want you to see, this is but2-one, this is butanal. Can you see 1, 2, 3, 4? So these two, they are functional isomers. Functional isomers. D and E. Why? Because this is 1, 2, 3, 4 butanal. This is butan 2-one. But. Therefore, what differs is the functional group. Okay. Okay. Now they say to us, write down the letter that represents a compound that is a ketone. E. The letter, it is number E. Has a general formula of CnH2n-2. This should be an alkyne. Remember, from an alkane, CnH2n plus 2, when I move to an alkene, I subtract 2 plus 0. When I move to an alkyne, I subtract 2 minus 2, but here it is just like this. So this is an alkyne. Which one is an alkyne? Number F. Number F is an alkyne. Can you see an alkyne? is an isomer of 2-methyl-butene. 2-methyl-butene, an isomer. Let's draw 2-methyl-butene. Okay, it is an alkene here, right? It is an alkene. Okay, if it is an alkene, so let's see 2-methyl-butene, but 1, 2, 3, 4. Then they are telling me here. Then on number 2, I have a what? A but. Sorry, methyl. I'll just say methyl like that, which is a like that. Then it means here I will just have like that. So which one is an isomer of this one? Remember, an isomer of this one can now be a chain isomer, okay? A chain isomer can now be what? It can either be a straight chain isomer like that, maybe something like with five carbons, but now the same functional group on carbon number 2. Okay. Do we have a 1, 2, 3, 4, 5 pent? Do we have pent 2 in? If you have pent 2 in somewhere or somewhere there, it means it is the one. Can you see now? Number C, it is the one. Number C, sorry. Number C, it is what? Pent 2 in. Okay. So the functional group of this one, it is pent 2 in, which is number C. Okay. Very, very, very good. Has the molecular formula as ethyl ethanoate. Molecular formula, ethyl ethanoate. Ethyl ethanoate, it is 2 carbons from alcohol, 2 carbons from carboxylic acid. It means now it has 4 carbons, and according to general formula, it is CnH2nO2. So it means it has H8O2. Which one is that? When I see this is an ester, right? And I know a functional group, or rather a functional isomer of an ester, it is what? Carboxylic acid. So I need to check a carboxylic acid that has 4 carbons. Which one is that? This one, number H. It is a carboxylic acid that has 4 carbons. Now let us be in a position of saying, okay, this 1, 2, 3, 4, we have 4 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. H8 O2. Therefore, it means now the most correct answer thereof, it should be number H. Can we see that? Number H. How cool is that? How cool is that? Now, they say to us 16.2.1, IUPAC name of A. IUPAC name of A for 3 marks. How very, very interesting. Now we want to check. Remember, this is an haloalkane. When we name haloalkane, we do not prioritize a functional group. We do not prioritize anything, right? We prioritize the one that gives us the least number of branches, okay? Longest chain, it is 1 carbon, number 2, number 3, number 4, number 5, number 6, okay? So this is the longest chain, 1, 2, 3, 4, 5, 6, right? But now we have branches where we have a branch on carbon number 2, branch carbon number 2, carbon number 3, also carbon number 5. Okay, and we have now a halogen on carbon number 2. So what is the name of this one? The name of this one, it is something like, how many methyls do we have? We have 3 methyls. So longest chain, it is hexane. Okay. The methyls that we have 1, 2, 3 methyl. So it's gonna be 2.4.5. 2.4.5 trimethyl. Then we have on carbon number 2, bromo. Okay. Yes. So now when we name, remember, we want to start with the one that has the smallest letter. This is B, this is M. Remember, when you name, the tri does not take part. Tri, di, yes. Tri, di, do not, we do not consider them when we name. What do I mean by that? It means now when we check which one is the alphabet that comes first, the tri, we do not check for it, check its letter. We start from the methyl. Okay. This just tells you the number of methyl we have. Okay. So it means I will start with 2 bromo, 2.4.5 trimethyl hexane. Can you see that? B comes before M of methyl. So it means this one should be 2 bromo. 2 bromo. 2.4.5 trimethyl longest chain hexane. Right? Yes. How interesting is that? Naming bromo, 1 mark, the 2.5 what methyl, another mark, then the hexane, another mark. How interesting is that? 16.2.2, they say draw a structural formula of F. Draw a structural formula. Write down. Obvious structural formula you need to draw. Structural formula of what? Of F. Where is F? 4.4 dimethyl pent 2 ion. So I look at this longest chain. The longest chain here on 4.4 dimethyl pent 2 ion, it is pent. So it means it has 5 carbons. 1, 2, 3. Okay, 1, 1, 2, 3, 4, 5. Then now, okay, 5 it is longest chain which is pent. Then now, on carbon number 2, I have an ion. On carbon number 2, I have an ion like that. Okay, carbon number 2, I have an ion which is triple bond. Then I have on carbon number 4 and number 4, I have a dimethyl. Dimethyl on carbon number 4. So if this is 1, 2, 3, 4, I have a methyl here, right? I also have a methyl there. Okay, it tells me we have two methyls. Reg, like that, like that, like that. How interesting is that? Then I complete the rest. You miss one hydrogen, you are out. You add an extra hydrogen, you are out. Here it is complete. This carbon here, it has one, 2, 3, 4. Maximum of 4 bonds, fine. Then this one here has 1, 2, 3, 4. Maximum of 4 bonds, it is fine. You add any hydrogen on this carbon, you are out. Okay, so how do they mark this? They mark this, they say, okay, do we see these branches here? If there are those branches, 1 mark, do we see the carbon, the triple bond on position number 2? Very, very correct. Then now everything it is correct, another mark. How interesting is that? How interesting is that? I'm removing it now so that we continue with other questions. Then on number 16.3, they say for compound D. So it means now whatever the sub-questions there, we'll be focusing on compound D. Which one is compound D? This one, our aldehyde here, like that, right? So they want what? Homologous series to which it belongs. Homologous series, it belongs to the aldehyde, right? Functional group of aldehyde, it is formyl group. How interesting is that? Already answered those questions here. Can you see? Homologous series aldehyde, functional group, formyl group. Interesting is that? Structural formula of its functional isomer. Very, very good. Very, very good. This is a what? A ketone. So an aldehyde. Can you see? Here it is, right? Here it is, right? I've drawn it here. Its functional, let me zoom out. Here is a ketone. So aldehyde, right? The structure of its functional group, functional isomer rather. Remember what is the functional isomer of aldehyde? Functional isomer of aldehyde, it is what? Ketone. So it means now I need to take this OH and take it to the next carbon. When I take it to the next carbon, it does not become positional isomer. Why? Because if I take this one to the next carbon, it is no longer an aldehyde. Why? An aldehyde always has this on the first carbon. The minute I shift this on the first carbon and move it to the other carbon, it is no longer aldehyde. It is now what? A ketone. So what I can do it is draw a ketone, but now draw this, but now shift this one here and put it on carbon number 2. Can you see that? So I'm going to put it on carbon number 2. And also I told you these are functional isomers. So I can say, I will draw something like, instead of putting it here, I'm going to put it in number 2. Or I can also put it here. It's fine, as long as I do not put it on carbon number 1. Okay? Then this will be very, very, very easy thereof for us to be in a position of labeling. Okay? How interesting is that? I did not put a hydrogen here. Why? Because it already has a maximum of 4 bonds. 1, 2, 3, 4. Can you see that? Yes. So now how do they mark this? The functional group of ketone, they mark, then everything is correct or mark. Without, you did not miss any hydrogen, you did not miss anything. Okay, yes. Now let's look at 16.4.1 for compound G. Compound G, it is butane. Okay, compound G, it is butane. Write down the name of its functional, also of its chain isomer. What is now a chain isomer of butane? If butane is like this, its chain isomer is going to be what? I'm going to have 3 and then put a branch somewhere here. Can you see that? Remember, chain isomer has different chains, right? But now the same number of carbons. So it means this one is the what? The chain isomer. So its name, it is what? Its name, it is 2-methyl propane. How interesting is that? 2-methyl. Why? Because I have a substituent in position number 2, and then the longest chain, it is prop. How interesting is that? Now on this one, they say to me, write down the balanced equation using molecular formula. Remember, molecular formula is CH4 and what? For its combustion. Very, very easy, this one. What do I mean by that? What is the molecular formula of butane? It is butane 1, 2, 3, 4. So you'll see it will be C4H. Remember, the general formula is CnH2n plus 2. So it means if I have 4 here, I will have 8, 10. You can also draw the structure and then count again. It reacts with what? With oxygen. Remember, a combustion reaction reacts with what? Oxygen. To form what? Water and carbon dioxide. But now it needs to be now a what? A balanced equation thereof. How can we do that? How can we do that? You're gonna say, okay, how many carbons do we have here? We have 4. On this side, I have 1. I need to put 4. If I put 4 here, remember, I always say balance the equation of, all right, balance oxygen last, okay? Yes. Hydrogen here, how many I have? I have 10. Here on this side, I have 2. So 10 divided by 2, it is 5. I need to put 5 here, right? Then oxygen, it is 4 multiplied by 2. In this case, it is 8 plus 4 multiplied by 5 multiplied by that one, it is 5. It gives me 18. So now oxygen at 13 on this side here, it is 12. 13 divided by, sorry, it is 2. 13 divided by 2, it is what? 13 divided by 2. But now we need to do what? We need to multiply everything. We need to multiply everything by 2. So to remove to what? So as to remove the fraction. So the final balanced equation is going to be 2. I'm multiplying everything by 2. CH4. When I say everything, I mean the coefficient. 2CH4H10 plus, when the 2 multiply this, it's going to just be 13 O2. Then multiply by 2, 8 CO2 plus 10 H2O. How do they mark this? You have your product, your reactant rather, first mark, your product, first mark, whether they are balanced or not. You having CH4H10 plus O2, it is a mark. On the products having CO2 and H2O, it is a mark. The last mark, it is now when it is balanced. So if you do not know how to balance this, you have 2 marks, it's fine. Okay, you can just write C4H10 plus O2 forming carbon dioxide plus water. You have 2 marks. You lose that 1 mark if you do not know how to balance. Okay, so yes, that was all for this type of question. Nomenclature, it is very, very interesting. You should be in a position of getting full marks. Okay, yes, thank you very much for joining me. Let's meet in the next video. I hope you enjoyed.